Alright, so in this problem they ask me, Max determine the product. So product means to multiply. It says 3 linear factors. So linear factors just basically means anything to the first power. So x plus 2 to the third power means x plus 2 times x plus 2 times x plus 2. Each of these binomials is a linear factor. So linear, linear, linear. If I multiply all of those, then let's see if our answer matches up with Max's. So when I do a problem like this, and comparing, contrasting, I always like to do the math first and then I compare my work. Obviously we know that he's wrong because there's a thumbs down and it tells us explain why he's incorrect. So if I take my answer, I'm going to draw a box underneath, and I can just multiply here. So I'm multiplying 2 binomials so far. I have x squared, 2x, 2x, and 4. And then when I combine like terms, I'm going to get something like x squared, these are like terms, plus 4x plus 4. And now I'm going to do this third binomial. And again, this one is, the reason why I'm drawing 3 boxes going across, it's 1 box per term. So 1, 2, and 3. Then I have x plus 2. I'm going to multiply. Class, go ahead and multiply those. X squared. X and 8. So our final answer is, you notice that if you write them in descending order and there's no missing terms, the nice thing about the area model here is it kind of shows us the like terms in diagonals. You see that? Our final answer is, tell me, x cubed positive 6x squared. We're just adding numbers in front. 12x plus 8. Raise your hand if you got that. So let's explain why Max is incorrect. Max is incorrect because you cannot use the power rule of exponents. We talked about this yesterday. Max thinks you can take this 3 here and distribute that power, so he would get x squared, or I'm sorry, x cubed plus 2 to the third power, which would be x to the third plus 8. That's what he thinks you can do. And the reason why this does not work is because it only works for, the power rule of exponents only works for multiplication. He has addition here. You see that? So, number 1 mistake, if you see this on your quiz, the student who's going to repeat the class is going to do what Max did. So don't do what Max did. How many x-intercepts does the function x squared to the third power have? How many zeros? Explain your reasoning. So remember, this is a cubic function. And actually today's lesson we'll actually graph these by hand. But I'm assuming that in my graph that it's possible that we can have this many x-intercepts. Count with me. Ready, set, go. That's the max. Now, if you actually take out your graphing calculator and put this in there, and I'm just going to type in x plus 2 to the third power. If you don't have math type, I use the caret button to move up for the exponent, and I'm going to press zoom and then standard. It changes my window to be -10 to 10, and then -10 to 10. And you'll notice that my graph is not a line, so it's not a linear function. It's not a parabola. It's not a u. And this is a cubic function. So in this case, we only have one. And we'll explain more as I give you guys more of today's lesson.